Welcome back to the deep dive. Okay, today we are diving headfirst into a real cosmic head scratcher. It's part astrophysics, maybe part science fiction. We're talking about 3A Atlas. It's this interstellar object that showed up and basically threw a wrench into a lot of scientific models. Our sources today cover the whole spectrum. We've got the official line from NASA, the big observatories, the consensus view. But then we also have this really provocative theory, mainly from Harvard astronomer Avi Loeb, which takes things in a very different direction. So our mission today, lay out the facts, get why most scientists are calling it a comet, but then really dig into this other idea. Could it be something else? Like an alien mothership? Let's get into it.
Right. So the arrival itself, July 1st, 2025, NASA's Atlas telescope down in Chile picks it up. And it really was like a cosmic party crasher.
Yeah.
Just appeared, no RSVP.
Yeah, the uninvited guest. And it makes a trilogy, right, after the other two.
Yeah, exactly. It's the third confirmed interstellar object. We had Oumuamua back in 2017, then Borisov in 2019, now 3I Atlas. And each one kind of rewrites the rules a little bit, or at least makes us question them. Makes you wonder what else is out there.
So how do we know it's interstellar? Not just like a weird cousin from way out in our own system. Speed, trajectory.
Yeah, absolutely. It comes down to the orbit. It's on a hyperbolic path.
Yeah.
And the speed is just nuts. 61 kilometers per second. That's what, over 136,000 miles an hour?
Whoa.
Right. And that hyperbolic trajectory, that's the key. It means it's moving too fast to be caught by the sun's gravity. It's not bound to our system. It's just, passing through. Here today, gone tomorrow, cosmically speaking.
Okay, so setting aside the wilder theories for a second.
Yeah.
When astronomers first saw it, what did it look like? What did the initial data suggest?
Well, initially, it looked pretty much like a comet. I mean, textbook stuff, almost.
Right.
They had the icy core, the nucleus. It had a coma, that fuzzy envelope of gas and dust around it.
Yeah.
And yep, a tail.
A cosmic snow cone with attitude, as one source put it. I like that.
Hey, yeah, it's a good description. Gives you the visual. That's what we expect.
But there's always a but, isn't there? This snow cone was acting up a bit, particularly the brightness.
Precisely.
Yeah.
That's one of the first odd things. It was reported as being unusually bright and active.
Yeah.
And this was still way out there beyond Jupiter's orbit. That's strange.
Why strange? Don't comets get bright?
They do, but usually closer to the sun. The heat makes the ice vaporize, creates the coma. The tail makes them bright. For this thing to be so active so far out, well, it suggests it's maybe more volatile or something else is going on. It was like glowing in the cold.
Okay, glowing in the cold. Weird. And then there's the chemistry, the actual stuff it's made of, that CO2 ratio.
Yes, and this is solid science spectroscopy. The analysis confirmed it's really rich in carbon dioxide ice.
Yeah.
The ratio is something like 8-to-1 CO2 to water ice, which is different. Comets in our solar system tend to have more water ice, or at least a different balance. CO2 freezes more easily at colder temperatures. So this heavy CO2 mix suggests it probably formed much farther out in its home star system, way beyond the snow line equivalent, like the LaCroix of space rocks, maybe. Lots of fizz.
The LaCroix. Okay, so unusual chemistry, unusually active, but still fits within the realm of natural comet, just a weird one from far away.
That's the consensus view, basically.
Yeah.
Unprecedented, yes. Definitely strange, but fundamentally natural.
Right. Hold that thought. Because now we pivot. Enter Professor Avi Loeb and the Harvard hypothesis. This is where we go from weird comet to, hang on, could this be an alien spacecraft, like a massive one, potentially miles wide?
Yeah, and Loeb's argument isn't just pulling ideas out of thin air. He focuses hard on the trajectory anomalies, the probabilities. He's essentially saying, look, the way this thing arrived, it looks suspiciously non-random, maybe even, designed.
Okay, designed how? What's suspicious about the path?
First big thing, its alignment with the ecliptic plane. That's the flat plane where all the planets orbit the sun, more or less.
Our solar system's main highway.
Pretty much. Now, for an object coming from interstellar space, randomly, the odds of it just happening to line up within 5 degrees of that plane are tiny, like 0.2% chance. You'd expect it to come in at some random steep angle, right? But this one, almost perfectly aligned.
Okay, that is statistically weird, like hitting a tiny target from light years away.
It does make you pause. And then there's the path itself. It includes these close flybys of Mars and then Jupiter. Loeb poses the question, is that just cosmic coincidence? Or is it like someone planned a route with specific planetary encounters? A scenic tour.
Scenic tour. Okay, and what about the tail? You mentioned tails earlier, but there's something odd here too, the anti-tail.
Right, the rare anti-tail. This is another point the counter-theorists raise. An anti-tail can sometimes appear to point towards the sun, which seems physically impossible.
Yeah, shouldn't it point away? Pushed by sunlight?
Normally, yes. Now, there is a standard scientific explanation for anti-tails. It's usually an optical illusion. It happens when we see larger dust particles left behind in the comet's orbital path edge on from Earth. So it's geometry, not new physics.
Yeah.
But the fact that this object displays one is added by Loeb and others to the list of geometric peculiarities. They frame it as another piece of the puzzle, suggesting maybe it's not just a simple comet structure, like physics hates this one weird trick, as the source puts it.
Okay, let's move from the path to the object itself, the physical characteristics.
Yeah.
The sources list like 9 specific anomalies that fuel the artificial origin idea. These are the real, moment.
Yeah, this is where the standard comet explanation starts to feel a bit strained for some observers.
Okay, number 1, size matters. Apparently this thing is huge. Its mass estimate is enormous, way bigger than Oumuamua was thought to be.
Yes, the scale is significant. It implies something either very large or very dense, possibly durable.
2, metal detector alert. What's this about nickel and iron?
Observations of the coma detected really high ratios of nickel compared to iron. Now, both elements can be in space rock, sure, but that specific ratio, it's unusual compared to known comets or asteroids. So the question becomes, is this just weird alien rock chemistry, or could it hint at, manufactured alloy?
Manufactured. Okay. Then number 3, the movement isn't quite right either. The zoom factor, non-gravitational acceleration.
Right. This means it's changing speed or direction in ways that the sun's gravity alone can't explain. It's got some extra push.
The standard explanation is outgassing, right? Like little jets.
That's the consensus, yes. Ice vaporizing unevenly, creating tiny thrusts. But the alternative theory, maybe it's not outgassing. Maybe it's an engine, controlled propulsion.
An engine, wow. Okay, number 4 is fashion faux pas. It turned blue.
Hey, yeah, this one's a real puzzle for the comet model. When I got closest to the sun near perihelion, it apparently showed an unexpected blue color.
And that's weird because
Comets usually get redder when they heat up. The intense solar radiation cooks the complex organic molecules on the surface, typically making them appear reddish.
So blue is the opposite of what you'd expect, going full Smurf mode, as the notes say.
Exactly. It suggests the surface composition, or maybe the size of the dust particles, is fundamentally different from what standard comet physics predicts. It's hard to explain with typical thermal models.
Okay, that blue color feels significant, like a real contradiction.
It's definitely one of the stronger points raised against the simple comet explanation. It implies something unusual chemically or physically about its surface or the dust it sheds.
All right, number 5, glowing personality, hints of self-luminosity, like it has its own lights.
Yeah, some reports suggested it might be emitting its own light beyond just reflected sunlight, artificial lights. Maybe the aliens forgot to turn off the porch light, so to speak. Needs more data, obviously, but it's on the list.
Huh, porch light.
Okay.
And number 6, the most sci-fi sounding one, mini-me release, little drones.
This was probably the most speculative, based on observations made when the object was behind the sun from our viewpoint. There were reports interpreted as possible small objects, mini probes or drones being released.
Like a mothership deploying scouts.
That's the narrative, yes.
Yeah.
We have to be really cautious with observations like that near the sun. Interference is high. But the fact it was even suggested adds fuel to the fire for the artificial hypothesis.
Okay, so if you stack up all those anomalies, the weird orbit, the size, the metals, the acceleration, the blue color, the lights, the potential probes, it leads somewhere pretty wild.
It pushes us into thinking about, well, more advanced concepts, like the dark forest scenario.
Right. Explain that. Not everyone might know the term.
It comes from science fiction Lou Sixon's Three-Body Problem series, but it's a serious thought experiment. The idea is, if there are other intelligent civilizations out there, maybe the smartest thing to do is stay hidden. The universe is like a dark forest. You don't know who else is out there. Revealing yourself could attract predators. So silence and stealth are the best survival strategy.
So, if 3i Atlas was an alien vessel, maybe it's trying not to be obvious.
Exactly. The dark forest idea suggests any advanced intelligence exploring would prioritize stealth. And this connects back to the orbit, that low orbital tilt, slightly retrograde coming in along the ecliptic. Theorists argue that's a sneaky approach. Harder for us to detect early, gives less warning time. Blends in with the local traffic, so to speak.
Okay, sneaky access. And the tech needed to actually do that and maybe even stop here.
Oh, the tech implied is mind-boggling. The hypothesis mentions something called a solar O-berth maneuver.
Which is?
Basically, using the sun's gravity and a massive engine burn at closest approach, perihelion, to drastically change velocity. In this case, it might involve braking significantly. If the goal was to slow down enough to actually get captured by the sun's gravity, instead of just flying through, it would require an incredibly powerful and precise maneuver like interstellar-level math and engineering, way beyond anything we can do.
Right. This isn't just putting on the brakes.
Not even close. It implies mastery over energy and propulsion on a scale we can barely imagine.
And the timeline for all this potential weirdness, when does it get close to Earth according to the predictions?
The projections put the closest approach, the potential rendezvous, in late 2025, November or December timeframe.
Okay, mark your calendars, folks. Cosmic Wonder or something else arrives end of next year. Which leads to the really uncomfortable question raised in the sources. If it is something advanced and potentially not friendly, are we ready?
Yeah, the blunt assessment seems to be probably not ready. It's a sobering thought. We don't really have a plan for that contingency.
Which is why it's crucial to circle back to the scientific mainstream, right? The voice of reason saying, hold on a minute.
Absolutely. NASA and the wider scientific community have explanations for these anomalies that don't involve aliens. Their official stance is still, essentially, it's just a comet, guys. A very weird comet, but a comet nonetheless.
So how do they explain away the weirdness, that non-gravitational acceleration, the zoom-zoom?
Outgassing. Simple as that. Comets warm up, ice turns to gas, especially in localized jets. These act like tiny natural rocket engines. They burp, basically. And those burps, even if small, add up over time and can change the trajectory in ways gravity alone can't account for. We've seen it on other comets.
Makes sense. What about the anti-tail? The thing pointing the wrong way?
That's standard comet science, really. Comet science 101, as the source says. It's an optical illusion. Depends on where the Earth is relative to the comet's orbit and the dust trail it leaves behind. Looks weird, isn't physically weird.
Okay. And the Nicolaian ratio?
Puzzling, yes. Definitely warrants more study. But it's not definitive proof of technology. We've only studied a tiny fraction of objects in the universe. Who's to say what the normal chemistry is for a rock formed in another star system? Maybe high nickel is common out there. It's an unknown, not necessarily ET.
And the government silence or slow information release. That always gets people talking Area 51 vibes.
The counter-argument is just bureaucracy. Science takes time. Confirming data, especially surprising data from multiple sources, is slow and careful work. It's more likely paperwork and process than a grand conspiracy.
So it all comes back to Occam's razor.
Pretty much. Which explanation requires fewer new assumptions? A really strange, unique, natural comet formed under conditions we don't fully understand yet. Or a miles-wide, stealthy alien mothership with advanced propulsion, weird metallurgy, potentially deploying probes, all arriving on a statistically improbable trajectory.
When you put it like that.
Right. The comet explanation, while pushing boundaries, still relies on known physics. The alien one requires invoking unknown technologies and intentions. So Occam's razor points strongly towards the natural explanation. Think horses, not zebras, or alien spacecraft.
Okay, so we're left with these different ways of seeing 3I Atlas, depending on which lens you use. You've got the romantic view. It's this amazing cosmic snowball, a messenger from another star, giving us a glimpse of alien chemistry, a natural marvel on a grand tour.
Then there's the math nerd view, maybe, focused on the data. A hyperbolic orbit precisely aligned with the ecliptic. An object that challenges our models, forces us to rethink interstellar object diversity. A fascinating puzzle.
And of course, the tinfoil hat view. It's the mothership. Miles wide, dropping probes, checking us out using a sneaky approach.
Hey, right.
What?
But regardless of which view turns out to be correct, and let's be clear, the evidence heavily favors a natural, if very strange comet. This object is incredibly valuable scientifically.
Yeah.
Either way, it's a win for science.
How so? What do we definitely gain, even if it's just a comet?
Well, first, it's an unprecedented chemistry glimpse, direct sampling via spectroscopy, of material formed around another star. That's like getting, mail from another solar system's formation process. Invaluable data.
Okay, cool.
Second, it challenges our understanding. It forces us to broaden our theories about what kinds of objects exist between the stars, how diverse planetary system formation might be. Science needs things like this to push forward. Complacency is the enemy.
True. Anomaly drives discovery.
Third, this whole debate, especially Loeb's hypothesis, forces us to seriously consider the ET tech identification problem. If something artificial did show up, how would we actually recognize it? What are the criteria? 3IADAS makes that a practical, not just theoretical question.
That's a really good point. We need a playbook for that.
Exactly. And finally, it provides powerful justification for future missions, like the ESA's Comet Interceptor. We need the capability to launch quickly and go meet these interstellar visitors when they arrive, study them up close. 3IADAS makes the case perfectly.
So the final verdict, weighing everything.
Based on the current science, the overwhelming probability is it's a natural wonder. A really, really weird, fascinating, carbon-rich, hyperactive comet from interstellar space. Pushing the definition of comet, maybe, but still natural.
But the door isn't completely closed on the other possibility.
Science never completely closes doors, not absolutely. But the burden of proof for the extraordinary claim rests heavily on the side of the artificial hypothesis, and it's not met yet. It remains a provocative possibility, but probably a comet.
And what happens next for 3I Alice? Where is it going?
It's still inbound, relatively speaking. The next major event is a flyby of Jupiter, expected around March 2026. That'll be another key observation point.
Any chance we can send something to meet it? You mentioned Comet Interceptor, but that's for the future.
There's some talk maybe NASA's Juno spacecraft, which is already at Jupiter, could potentially get a unique look as 3I Atlas passes through the Jovian system. Depends on orbits and timing, but it's a possibility being explored.
So continued monitoring, more data, hopefully. We'll need that transparency.
Absolutely. The more eyes on it, the better the data, the clearer the picture will become. So ultimately, you, the listener, are left with this choice in interpretation based on everything we've discussed. Is it an extreme but natural visitor challenging our assumptions? Or the very first hint of something truly paradigm shifting? It's probably just a comet, a really, really cool comet. But wouldn't it be something if it wasn't?